One of the operations that's often performed on arrays is searching an array. Consider this integer array defined in line 7, and let's say we want to search for number 68 in the array. There are different algorithms for this, but one of the famous one is the binary search. And in order to apply the binary search, the array or the list must be sorted to begin with. And if you look at this list, this array, it is sorted starting from 0, smallest number, all the way up to 91, the largest one. And we are, let's say, searching for the key 68. Now let me show you this PowerPoint slides that describes the algorithm. This is the same list of integers. The index starts from 0 and goes all the way up to 10, and we are searching for the key 68. Since the array is sorted, what we do, we look for the middle index. In order to find the middle index, we add the upper index, which is 10, to the lower index, which is 0, divided by 2. That gives us the midpoint, which is 5. So index 5 is at 41. So we find the middle of the array, the element in the middle of the array, and compare the key we are searching for with that middle element. And in this particular case, 68 is not equal to 41, but we notice that 68 is larger than 41. And since the array was sorted, we conclude that if 68 is going to be in this array, it has to be in the upper portion of the array. So what we do, we basically move the lower index of the array all the way up to 1 more than the midpoint, which will be at this point, it will be index 6, and keep the upper index the same as before. Now, the lower index is 6 and the upper index is 10. We combine the two indices, divided by 2 in order to find the midpoint of it, and the midpoint is 8. So that midpoint index is 72. So element 72 is at index 8. Compare 68 with 72. We notice that 68 is smaller than 72, so obviously we have to now shift the upper bound to the left. And in fact, we change the upper bound from index 10 to index 7, 1 below the midpoint here, which was 8. So if 68 is going to be in this array, it's going to be between these two cells basically, at cell at index 6 and cell at index 7. We find the midpoint of those two. 7 plus 6 divided by 2 is 6. That gives you 55. 68 is greater than 55, so we have to push the lower index more to the right. So the lower index was at 6, now we move it up to 7. So the right index or higher index and the left index or lower index, both of them are at 7 now. So we add them, divide by 2, that gives you 7, which is the index where we have to search for 68, and it actually matches up. 68 is equal to 68. So basically the binary search applies to a sorted array, and it basically keeps bumping to the left and right in order to find the key that it's searching for. If the search is successful, the algorithm, the binary search, will return the index of that particular element. So in this case, the algorithm will return index 7. That's where 68 is found. And if the search fails, -1 will be returned, which is an invalid index. So this algorithm, to be programmed, will go right here. We have the list here. We have the array, integer b. We need to have our function. Return type of the function is an integer. That integer is going to be the index. It's either -1 if the search fails, or it will be the index where the element is found in the array. Let's call this binary search. And the parameters to this binary search is a constant integer array. Let's call it x. The constant because we are not going to change the values of the array x. We also look for the key, or the second parameter is the key that we are searching for, and finally we need to definitely have the size of the array as well. So that's the header of the function. What we want to do first, this is the lower index. We're going to set the low index to 0, and then the higher index, oops, that's an integer. We are going to let that to be equal to size of the array, which is again always one more than the valid index. Subtract 1 from it. Now we go through a while loop, and as long as this high index is greater than or equal to low index, we continue to execute this block of code. We need to find the midpoint or middle index, and that is obtained by basically adding the high index and the low index and dividing it by 2. That's an integer division, by the way, so it will be an integer. Right? And then going through a comparison. If the key is equal to the element at this mid-index, then the search has been successful. We are fine, and we can return that mid-index basically. Else, if they are not the same, if the key is not equal to that middle element, then supposedly this key could be greater than the element in the middle, right? And if it's an x, not a, x of mid. If that's the case, then we have to basically shift the low. You're gonna update the lower index to the mid index plus 1. So it's shifted to the right in a way, right? This is else if. Just clean this up. And finally, the last clause is where the key is less than midpoint. In that case, we have to bring the high index lower. We have to shift it to the left. So high will be equal to mid minus 1. Right? And we'll go through this. And if the search is successful, eventually line 12 will be hit, and that midpoint will be returned. If the search is unsuccessful, you'll come out of this while loop, and what happens, you have to return -1 because the search failed. So continuing with this, let's go to the main, and let's have cout. Let's call this binary search and search for the key number 68. So number 68 is at index bsearch. I'm going to call the function. Send to it our list, which is b, the key 68, and the size, which is 11, and then end line. Let me make sure that we have the binary search correctly created there. There is an R missing in here. There you go. And this is fine. System pause. And we'll return 0. And this should work. And index 7 should be returned because the search is successful. So we'll go for it. We'll run this program. 68 is at index 7. We can search for other keys. For example, I can search for, let's say, 91, the last element in the list. Let's search for 91. It is at index 10 gives it to us. And let's search for a key that is not there. Let's say 14. It will come out and say that it will return -1, an invalid index because the search failed. -1.